This example is like what we did earlier with compressions and stretches, but this time we are adding the translations to it. So this is a pretty complicated example because we've got our original function, which is the red graph, and we've got our new function, which is the blue graph. So we start the same way that we did when we looked at method 1 earlier, where we look at our horizontal distances. Because we need to find out all of the transformations that have happened to get from one to the other, and then once we have that, we'll be able to write the equation. So the horizontal distances, we're going to start on our red graph and say, how far is it from A to B? Horizontal distance, we start at 0, and B is at 2, so the horizontal distance from A to B is 2. The horizontal distance from A prime to B prime starts at -2 and goes to 0, is also 2. So we can say that x has been multiplied by 1, but really we can say that nothing has happened to x. We don't have to add any horizontal stretches or compressions because it stayed the same. When we look at the vertical distances, first from A to B, well, A starts at +8 and B is at -8. You have gone down. So here it's important, because we've gone down, we write -16. And from A prime to B prime, we're still going down, but now we're only going down 8. To go from -16 to 8, you would have your y values have to be multiplied by 1/2. What makes this one different is that after figuring out what your transformations are, what you need to do is temporarily, I'll just say temporarily, because this isn't part of your final graph, temporarily apply both, and I'll write stretches / compressions, even though right now we only have one compression. But you're going to temporarily apply that to your original graph, which is your red one, y equals f of x. So x doesn't change, but if I temporarily applied y by 1/2, what would happen to this point A, 0,8? Where would it go if you multiplied the y by 1/2? It would come down to 0,4. So we'll put a dot at 0,4. What would happen to 2, -8? It would come up and be at 2, -4. So these are our temporary points that are going to help us. Because when you're working from left to right, you do your stretches and compressions first, and then you do your translations after. So this is doing temporarily that second set of points after your stretches and compressions. Now, can you see, if I had to move this point to this point, and this point to this point, that I could do so with translations? I'd have to go in which direction? I'd have to go to the left 2 and down 4. So we can add that sort of as a note. Now we can see that we need to go 2 to the left and 4 down. And you have all of your transformations now. X is multiplied by 1, y by 1/2, left 2, 4 down. So we can write our final equation in terms of f, y by half would be out in front. Inside, the x doesn't, it gets multiplied by 1. You don't need to show that because nothing's happened. The only thing inside is 2 to the left. We can show that with an x plus 2. And then 4 down minus 4. So to recap, what we did was first we figured out our stretches and compressions. Then we temporarily applied that to our original graph to see where those points would have gone. And that's where I did those green points on the graph. Because it's very hard to see how something has been moved left, right, up, and down without doing that. And then once you have those green points, now you can see that you can move the same amount left and the same amount down and end at the blue points, A prime and B prime. And once that, then you can write your equation. Okay, only one question for practice on this one, which is number 9.